Everyone. Thanks for joining today's webinar. My name is Lauren Adey, and I am the Additive Manufacturing Specialist here at EAC. Let's go to the next slide. So before we begin, today's session is being recorded, and barring any technical difficulties, everyone will receive a replay after the webinar. And throughout the presentation, please feel free to drop any questions you have into the chat, and we'll make sure that we try and answer those as we go along. We also have some fun polls throughout the presentation, so keep your eyes peeled for those. And also, following our session, there will be a short survey that will appear on your screen, and we would greatly appreciate if you guys could answer those questions for us after the webinar. So today's presentation will be hosted by myself, as well as Levi Smith, our Formlabs Channel Sales Manager. And on our agenda today, we will briefly introduce EAC and Formlabs, and then quickly jump right in. So our mission at EAC is to transform the way that companies design, manufacture, connect to, and service their products. And to keep it simple, we really just help companies to bring products to market with the right tools and resources to become successful. We offer a range of products and services, including CAD, simulation, product lifecycle, and service lifecycle management software, as well as our Formlabs offering. We also help to implement the Internet of Things and augmented reality into business strategies. We offer to help with design and engineering projects, and we provide training courses and webinars for continuous learning. And we've also partnered with Formlabs to deliver the industry-leading 3D printing solutions, ultimately to help our customers build high-quality parts in the shortest amount of time. And currently, we're headquartered in Minneapolis, but our team is spread out through the country to ensure that we always have someone local that you guys can count on in a pinch. And today we're going to cover design for additive manufacturing best practices, specifically related to the Formlabs 3L. And it looks like we're on to our first poll, so feel free to interact right on your screen and share if you guys outsource any of your 3D prints. I'm going to give everyone a few minutes to respond. And just note that these responses are anonymous and no information will be shared or shown. Okay, so with that, I'm going to hand it over to Levi Smith from Formlabs for the technical part of the demonstration.
Terrific. And Lauren, really appreciate kind of just the introduction there. I'll go ahead and bring up our mission statement here. And just before I kind of get into who Formlabs is and what we're all about, I kind of like to start where, kind of our approach to partners like EAC. And, in terms of a value-added reseller, EAC is almost exclusively what we're looking for on a regular basis, right? We're very keen to find the right partners that can support and extend who we are into the marketplace with, the current customers they work with, the current products, the portfolio products they offer. EAC absolutely represents that. I think we've been on board with EAC for close to 5 years now. It's been a terrific ride just in terms of the Form 2 to the Form 3, 3L, obviously the Fuse 1. And the best part about working with a partner like EAC is that experience, right? So it's a portfolio of products, and really what you have to come to them with is just some type of application problem. And whether that is Formlabs or some other product they offer, they're going to be very keen to give you a holistic solution to that application problem. So again, today we're going to kind of walk through some design guidelines. I'm going to give you just a quick rundown of who Formlabs is. But most important, any additional questions that pop up, definitely reach out to Lauren. She's going to have a little bit of a less biased point of view than I will with regards to Formlabs. So I always like to kind of start there. In terms of who Formlabs is, our goal, our mission statement is to expand access to digital fabrication so anyone can make anything. And it's really about democratization of this type of technology. There's two key questions we ask ourselves every day, and that is, how do we make it easy to use, and how do we make it more versatile? In terms of that first question, it really comes down to delivering this technology as many people as we can, and making it as easy to use as possible. So, a great example of that is our user base. 44% of our users have little to no 3D printing experience before working with Formlabs. And we're not just talking about engineers that have FDM experience moving over to SLA. We're talking about folks that come from the subtractive space, maybe not even from the subtractive space. This is their first introduction to 3D printing and SLA. So the ease of use speaks for itself. The second component is obviously materials and versatility, and we really equate versatility to materials. So I think when we launched the Form 2 back in 2015, we maybe had 4 to 5 materials to work with. I think we have over 30 plus materials to work with today. It's very easy to use, very versatile, and that's really what we're all about over at Formlabs. And just a quick timeline on Formlabs as a whole, you know, we initially started in our founder's basement, Max Lebowski, back in 2011. You know, he had been in, he just graduated from MIT, was really excited about SLA technology as a whole, and really wanted to just bring this technology to as many people as he wanted to, as he possibly could. And that's when he built his first inverted SLA in his basement, and essentially got together with a couple of friends, wanted to bring this technology to the world, put that first Form 1 up on Kickstarter, wanted to raise a couple $100,000. In fact, within the first 30 days raised, I think close to $3 million. I think we had 2,000 backers. And that's when we really saw that there's a potential market for this type of technology. From there, we launched our Form 1 Plus, again, an iteration and improvement on the Form 1. The Form 2 was a real game changer for us in terms of ease of use, the type of markets we had access to. We put about 50,000 of those Form 2s out in the world, and that's, you know, about 4 years down the road, we iterated on that design, and we built the Form 3 3L with our new LFS technology. Later on in 2019, we launched the Form 3B, which is our biocompatible printer, specifically for, you know, the medical industry, the dental industry, and then of course the Fuse 1, which has been, you know, something we announced a little bit premature, but we've actually relaunched it in January of this year. We're already shipping it. Really excited about bringing SLS to the market here. So just want to give you a quick rundown on who Formlabs is. And really today, it's about design tips for the Form 3L. We're going to go through a couple of examples, specifically just a couple of questions that commonly come up, and just the design tips associated with Form 3L and our LFS technology. So question 1, what's a good example of designing for additive manufacturing? And the place we usually start, a great example of this is some of the work we do with Ashley Furniture. Their Arcadia facility has, I think, 4 or 5 of our printers running, you know, doing at least 40 hours of work each with regards to specific fixtures. This is a great example of a set of alignment pins that they use. And obviously we showcase it at all our events. But, you know, in terms of an unoptimized build for this alignment pin, you know, you have a yield of roughly 9 parts, 818 milliliters of resin, and a build time of roughly, you know, a day and a half. And if we were to optimize this for additive manufacturing, you know, we can increase by a part, decrease resin to 527 milliliters, and build time to about 28 hours as opposed to, I believe, the 36 hours it represents. And in terms of what you're saving, right? So let's call it a 90-part run on 10 builds. You're saving close to 88 hours, almost 3 liters of resin, which equates to about $500, and 22 minutes of cleanup with regards to support and removal. And really what this comes down to is roughly 15 minutes of design time with regards to optimizing that part. And if you look at the unoptimized part, for example, you know, it's a solid geometry, so it's obviously going to be costly in terms of time and material. You have a ledge, which is going to require support structure, and then there's a lack of a chamfer lead in, which makes part removal a little bit tricky. And so these are the 3 things we focused on specifically with designing this for our 3D printer. We shell the interior, which is obviously going to save a lot of material. We put ribs in there to retain part strength and stiffness, of course. And then, of course, you know, we built a lead-in chamber. With the hollow geometry, we needed to create vents, so you didn't have any cupping associated to this print. And then obviously we took a hard step on the ridge right there and replaced it with a chamfer. And these 4 design components really allowed us to optimize this build. So just want to give you guys a quick example of optimized versus unoptimized. We'll go back to the other one real quick, just a couple of you know, quick showcases of what we really kind of focused on. And that 15 minutes really saves a tremendous amount of time and money. So just a little bit of thought process into that, and obviously you guys can optimize pretty quickly. The second question that constantly comes up, obviously, is how does SLA printing work? And really what I want to focus on here is our new process, low force stereolithography. This really plays a crucial component into the Form 3L, how we're able to create an inverted SLA with 5 times the build volume of the Form 3L. And there's 2 key components to it. The first being the LPU, or the laser processing unit. And I love this kind of guide that we put together here. But the LPU on the Form 2 was a stagnant LPU. So it actually pointed the laser across the entire build platform, whereas with the new LPU, it actually runs in the x-axis. Huge benefit of this is obviously the modularity of the printer. The second, of course, is the fact that you're going to have crisp, clean edges on all your parts, regardless of where you build within the Form 3L. The second component, and obviously the most important, is this flexible tank that we use with regards to our low force stereolithography. So this flexible tank reduces peel force by roughly 10-fold. And that's very crucial. Just on the Form 3 alone, creates more high fidelity parts, more reliable parts. I think a huge benefit of eliminating peel force is the type of materials you really get to create, right? So we're able to create more viscous materials. We're really able to up the game with regards to versatility. That's been crucial. If you look at us in 2020, I think we launched close to 15 new materials alone. And that's a byproduct of low force stereolithography and the elimination of a lot of the peel forces and a lot of the forces associated with printing in an inverted SLA. But again, you eliminate peel force, you're able to build much bigger. And that's how we were able to create the Form 3L. And this is just an example. I think this is from New Balance. They're creating goodness, I think that's like a size 13 insole. But it allows us to build bigger. And that's really a key component of Formlabs, our low force stereolithography, being able to build bigger. And obviously we got some great, it's just a part we do with Dyson, and just roughly what the output looks like on a Form 3L. So in terms of question 3, what are support structures for and when do you need them? And at Formlabs, we're very keen to focus on a full solution. So it's not just the printer itself, it's the slicing software and preform to the post-processing with our form wash and form cure. Here, we're really talking about, our preform or slicing software. So support structures exist to deal with 2 main print process considerations. You can't print on air, and the forces of print process, either machine movement, thermal changes, or both, will cause parts to move and distort. So good print process design can compensate for those forces, but only to a point. Where the forces exceed what the print process can manage or thinks it can manage, support structures are added to the build. And what you have here is just a screenshot of our preform software. And the bright red areas show geometry that's not fully supported. The darker red areas show geometries that are partially supported, but this is the beauty of our complete solution is, the preform software is very intuitive with regards to the algorithms that we build into it. You drop that STL into preform, it's going to give you a really good feel for what you can do with what you can build. And I think something to keep in mind as well as you work with preform in your print process is start conservative, right? You have a new part, maybe you have a deadline. Be conservative in terms of support structure, but once you have that first successful part, we make sure our algorithms in preform are very, very conservative. So if you have that first successful part, maybe you have a lot, maybe it's a little bit over supported. The second thing you want to do is start to draw back some of that support structure to see if you can get away with a little less material, a little less post-processing. Because again, it's conservative because we want people to have a lot of print success. But once you have that successful part, start to dial it back, get real aggressive with what you choose not to support, if you will. So another component I just want to touch on is just a good visual on the print forces that you have both up and down and side to side, and the part that's being printed and processed. So obviously overhangs are a crucial component here. Definitely keep that in mind when you have large overhangs. That's where the support structure is absolutely going to be necessary. just a consideration you always want to think about. And I want to do just a quick example of our preform software in action here. Again, it's very intuitive in terms of the setup. Over to the right, you're going to have some print statistics in terms of the layers, the volume. It's going to give you printability. It's going to highlight any components that aren't potentially supported. And obviously, we have an auto-generate support structure tool that's very helpful there. So give you a feel for what this looks like. And in terms of this part, let me just get to the next screen here. Fun fact on this one, this is actually Medtronic's OEM enclosure for their ventilator system that they opened up last year, I think in April or May. So again, came out fantastic. You can see where the support structure is, how we auto-generated it. But again, it's just a fantastic part to kind of showcase our preform software on the Form 3L. So question number 4, can my part be printed directly on the build platform? And usually in this situation, especially if I don't have a visual, I'm usually going to say it's going to be geometry dependent. That's absolutely the first consideration here. You can absolutely print on the build platform, but it's going to be geometry specific. I want to give you guys a couple of examples of that. On the left, you have our Formlabs logo. It's more or less like a tie clip. And you can see the parts highlighted in red. Again, this is not something you want to print directly on the platform. Acceptable, again, you want to make sure that you have self-supporting geometry, and that's what you see on the right there as an acceptable form. So I want to give you a couple examples of that. The vacuum nozzles here, again, great example of designing for additive, especially around our SLA Form 3L. Obviously, it's a hollowed out part. You have a lead-in chamber on the bottom just to make support removal easy. Again, it's hollowed, so we put in vents. But again, a great part, a great example of design for additive with regards to the Form 3L. And you can see another example here in terms of support removal. Again, we put a essentially support structure lead-in chamber on the bottom there, and that really allows for a seamless removal process. So just to give you another visual here, part removal with a straight wall, especially, this is usually okay depending on the type of material you're using. If you're using one of our stiffer materials, we're absolutely going to recommend a lead-in chamber, which you see on the left there, just depending on the part. Again, maybe if this is printed in durable, it's a little bit different. You got a little bit more flexibility on that part. But again, if you're using some of our stiffer materials, you definitely want to do a lead-in chamber there, which is what you see on the left. Perfect. So let's go ahead and get into the design guidelines for the 3L, 3BL. And I think what a lot of you on the call will see here is we've been able to really mimic the design guidelines on the Form 3 to the Form 3L. So you're going to see a lot of similarities there. I think that's really exciting because whether you're building in volume, smaller parts, or whether you just need to build large SLA parts, you're working with some very similar design guidelines there. So minimum hole diameter is 0.5 millimeters. I think this is exactly the same on the Form 3. Same thing with the minimum drain hole diameter of 2.5 millimeters. A good example of that is this spoon that we did with a specific vendor we work with. And again, we got tons of these types of examples out there. In terms of overhangs, so an overhang refers to a part of the model that sticks out horizontally parallel to the build platform. And in terms of minimum unsupported overhang length, you're looking at 5 millimeters, and minimum unsupported overhang obviously refers to the angle from horizontal that the overhang sticks out, right? So recommended is 10 degrees from level. And again, keep in mind with regards to these guidelines, they are a rule of thumb. These things also become very geometry dependent. But our design guidelines tend to be conservative as well. So if you have a lot of success following that design guideline and you want to push the envelope, we absolutely recommend that. We always just say start here and then get more aggressive as you see part success on the Form 3L. So another good example of self-supporting geometry. Again, you have overhangs, you have chambers. I believe this is printed in our rigid 10K. So again, want to make sure we include as many visuals as we can on this. Question number 6, what size features can I print using the 3L, 3BL? So a couple of good examples in terms of our design guideline. Minimum supported wall thickness. So a supported wall is one that is connected to other walls on 2 or more sides. and are recommended. A supported wall smaller than 0.2 millimeters may warp during the peel process. So again, that's our recommendation. Minimum unsupported wall thickness, again, with us is 0.2 millimeters. Anything below that may warp or detach from the model during printing. So just to give you a couple of examples, again, very, very similar to what you're going to see on the Form 3L. And again, a great example of that is the work that we've done with Black Diamond. Again, they've been a beta tester for quite some time. You can just get a good feel for the parts that they were prototyping in this example right here. Again, we have another great example on our website with regards to one of the helmets they built for the same series of products. So again, just giving you a couple of design guidelines here that really are useful. Minimum embossed detail. Okay, so embossed details are shallow raised features on your model, such as text. For us, our recommendation is 0.1 millimeters. In terms of minimum engraved detail, and again, engraved details are imprinted or recessed features on your model. Our recommendation is 0.15 millimeters. And a great example of the type of detail you're going to get is some of the work we do with Aaron Sims. Again, this is the design studio that also created a lot of the work for Stranger Things. Again, really good customer of ours, but want to give you some great visuals in terms of that embossed detail right there and what you can kind of get away with. So last question, how much space do I need to put between parts on a 3L, 3BL? So minimum clearance, again, the amount of distance needed between two moving parts of a model. And for us, again, very similar to the Form 3, you're looking at 0.5 millimeters of clearance. And right here, we just want to give you a couple of examples of us designing for additive around our SLA printers. Right here, obviously, you're going to have clearance. It's a self-supporting model. You can see where the holes have been placed, the overhangs, if you will, and the self-supporting. Obviously, we've built in a chamfer there as well. The wall thickness, and of course the embossed details. So just in terms of our approach, those 6 things are really what we're thinking about in terms of design for additive. I guess with that said, I was going to move it over to questions.
Perfect. So I do see a question in the queue. Again, if you have questions, now is the time to put them in. One of the questions is, what flexible material is available for the 3L? They tried to get material from flexible and elastic, and it's not available to use on the 3L right now. So do you have any insight to that, Levi?
Yeah, so the place I kind of like to start is the approach that we take with our Form 3L and dialing in those materials. Lauren, I know we can send over. I know we have a release guide in terms of all our materials on the Form 3L. I got to double confirm on our flexible materials, but I know we have a design. I just have to take a look at our internal guideline there. But in terms of the process, we want to dial in these materials to a specific success rate. And that requires just, obviously updates to the preform, the firmware. I know some of these materials took a little bit longer, but I think, if I'm not mistaken, our flexible materials are or should be available at this point. So I'll double check, Lauren. I'll send you over the guide that we have on that, just so you have it.
Perfect. And then, will this presentation be available for download? I don't know specifically about downloading or not, but I know there is a replay that will be sent out to the email as soon as we are finished. Let's see. Is there a reason that parts would get harder to remove from the build platform over time?
I'm wondering if there's a specific example there. So in terms of the build platform itself, one of the things that's a consistent kind of concern that people have is they're afraid they're going to damage the build platform. And the build platforms are rather robust. You can scratch them up. That tends to be a good thing with regards to part adhesion, excuse me. So I think maybe over time, depending on how scratched up that build platform might be, they might be a little bit harder. That's the only kind of conclusion I can draw there. But for the most part, yeah, it really comes down to how you build that part. Are you building it directly on the build platform? If you are you building a lead-in chamfer into that part to make it a little bit easier to remove? Is it just a ledge that's built directly on the build platform? It's really going to be part geometry dependent, excuse me. And at the same time, yeah, as that build platform gets scratched up, it tends to have better adhesion, which might lead to a little bit harder time to remove that part.
Okay, perfect. And then I did just get a note as well that the flexible and elastic are available in the beta mode for the Form 3L.
Perfect, perfect. So
I can get more information on that and send it out after.
yep, and Lauren, I know we have the beta versions, I think, on the support page. If you'd like to download that and start working with those materials, you absolutely can start printing with those.
That's perfect. Okay. And then someone also asked, how in the software do you build directly on the platform? They always get an error.
So there should be some tools that you can use within the preform software. Essentially what you want to do is remove the raft or the little boats that go, I think those are almost standard, but you'll have like a click in box that you can hit that will allow you to build, essentially eliminate rafts, and that should allow you to build directly on the build platform.
Okay, perfect. I don't see any other questions at this time. So, thanks to everybody for joining us today for our webinar for the best practices for designing on the Form 3L. We appreciate your time, and you guys took with us this morning, and we appreciate everything. As long as there are no technical difficulties from recording, you guys will be receiving the replay of the webinar in your inbox, and we hope to see you guys at future EAC webinars, and have a good rest of your day.
Absolutely. Thanks, everybody.